Hello students, now I am going to explain detailedly about Gauss theorem in a vector integration in a model 2 in the subject Advanced Calculus and Numerical Methods. So before going to do the problems based on this Gauss divergence theorem, first we'll see the statement of this Gauss divergence theorem. Proof is not there in your syllabus. You have to remember only the statement. The formula alone you have to remember here. Okay, the statement will be like this. If vector f is equals to f1 I cap plus f2 j cap plus f3 k cap is a vector point function having continuous functions in the region V bounded by a closed surface S, then triple integration del dot vector f dv which is dr which is equals to double integration over S vector f dot n cap into ds, where n cap is the unit normal vector to the surface S. So here vector f, one vector equation they will give. So this Gauss divergence theorem is related to the triple integration. It means it is related to the volume. So that you have to remember. The equation for this is triple integration del dot vector f dv which is equals to double integration over s vector f dot n cap ds. This is what the formula. You have to remember only the formula. Okay, now based on this we'll solve few problems. So we'll see the first problem. Evaluate vector f is equals to x square minus yz into I cap plus y square minus zx into j cap plus z square minus xy that into k cap. Taken the rectangular parallelepiped, x is lies in between 0 to a, y is lies in between 0 to b, z is lies in between 0 to c. Find triple integration over v del dot vector f with respect to v. You just read the question. Here we have to find out the value of triple integration over v del dot vector f dv. Del dot vector f is nothing but what? Divergence we have to find out for this f. Vector f anyhow they given in the question. That is x square minus yz into I cap plus y square minus zx into j cap plus z square minus xy into k cap. Along with that they given the values for the limit values for xyz they given as 0 to a, 0 to b, 0 to c. Okay, now first what we have to do, we'll go for find the divergence first. Vector given vector f you just write as it is. That is x square minus yz into I cap plus y square minus zx into j cap plus z square minus xy into k cap. Now we'll find out this divergence of f will find out now. So here first we'll find out the divergence of f, that is del dot vector f we have to find out. Del, the definition of del we have to substitute, that is dou by dou x into I cap plus dou by dou y into j cap plus dou by dou z into k cap dot vector f, the given vector f we have to substitute, that is x square minus yz into I cap plus y square minus zx into j cap plus z square minus xy into k cap. Now two vector equation is there, you just in between dot product is there, you just to go for multiplication. If you go for multiplication means, so I dot I is 1, any other term is that will become a 0. So dou by dou x of x square minus yz plus dou by dou y of y square minus zx plus dou by dou z of z square minus xy. On simplification, first term do the differentiation with respect to x partially, that will become 2x. Second term do the differentiation with respect to y partially, that will become 2y. Similarly the third term will become 2z. You just take 2 as a common, that will become x plus y plus z. So solution of divergence of f will be 2 into x plus y plus z. So now you just write the formula for this Gauss divergence theorem. That is, we know that triple integration over v divergence of vector f into dv. So that will become triple integration means x equals x is varying. In a question clearly they given the limits of x, y, z they given, that you just substitute it here. That is x equals to 0 to a and y is 0 to b, z is 0 to c. So this one we got it from that the Gauss divergence theorem only. Now the solution of divergence of f will be 2 into x plus y plus z, and then dv is nothing but dx dy dz. Now this it is a triple integral equation. Now we have to do the simplification. 2 into integration x equals to 0 to a, y is 0 to b, you just write as it is. Inside the term x, that integration with respect to z we have to do first. That will become xz plus yz plus z square by 2. So limit value 0 to c, you just substitute upper limit and lower limit in place of z. So that will become cx plus cy plus c square by 2. So now you just go for do the integration is with respect to y, so that we are getting the equation cxy plus cy square by 2 plus c square y by 2. You just substitute the limit in place of y has 0 and then b, upper limit is b, lower limit is 0. On simplification we are getting bcx plus bc b square by 2 plus c square b by 2. Now you this equation you just do the integration is with respect to x, so that will become 2 into bc x square by 2 plus b square cx by 2 plus bc square x by 2. Limit is 0 to a, upper limit is a, lower limit is 0. On simplification we are getting abc, that into a plus b plus c. This is what our required solution. Now we'll see the next problem. So the next problem will be like this. If vector f is equals to 2x square minus 3z into I cap minus 2xy into j cap minus 4x k cap, evaluate triple integration over v del dot vector f dv, where v is the region bounded by the plane 2x plus 2y plus z, which is equals to 4. Here clearly they given the vector f. The given vector f equation you just write, that is 2x square minus 3z into I cap minus 2xy into j cap minus 4x into k cap. So for this vector f you just find out the divergence. So divergence of vector f, that will become del dot vector f. Write down the definition for del, that is dou by dou x into I cap plus dou by dou y into j cap plus dou by dou z into k cap, that into vector f. The given vector f equation is 2x square minus 3z into I cap minus 2xy into j cap minus 4x into k cap. So on multiplication of these two vector we are getting dou by dou x into 2x square minus 3z plus dou by dou y minus 2xy plus dou by dou z into minus 4x. So now first term do the differentiation is with respect to x, we are getting 4x. Second equation minus 2xy, that do the differentiation partially with respect to y, we are getting minus 2x. Last term will become a 0. On simplification we are getting solution as 2x. So now the given surface bounds by the planes x equals to 0, y equals to 0 and z equals to 0. So lower limit it is a fixed, that is 0 0 0, and upper limit we have to find out with the help of the given plane. So that will become the limit value of x is 0 to 2, y is 0 to 2 minus x and z is 0 to 4 minus 2x minus 2y. By using this Gauss divergence theorem, triple integration over v divergence of f with respect to dv, which is equals to integration x is 0 to 2, y value is 0 to 2 minus x and z value is 0 to 4 minus 2x minus 2y. So now you just substitute the solution of the divergence of f, that is 2x with respect to dz, dy and then dx. So first we'll do the integration is with respect to z. So that will become x into z in the inside integral. Limit value is 0 to 4 minus 2x minus 2y. Substitute in place of x. On simplification we are getting x into 4 minus 2x minus that 2y. Again this equation you just do the integration is with respect to y you just do and substitute the limits of y that is 0 to 2 minus x. On simplification we can write that equation will be like this. Finally we have to do the simplification. Finally we are getting equation as x cube minus 4x square plus 4x. This equation do the integration is with respect to x and then substitute the limit 0 to 2. Upper limit is 2 and lower limit is 0. On simplification we are getting that required solution as 8 by 3. This is what our required solution. So still many problems we can solve. Here only few problems I solved. Thank you.